Hello friends, we will study today aromatic compounds. So in aromatic compound, we will study nomenclature of benzene derivative and structure of benzene. So in aromatic compound, we will study benzene and its derivatives. So this is the structure of benzene, and this is structure of toluene, and this is orthoxylene. These are aromatic compound. If you see around yourself structure of drugs, these drugs contain some aromatic compound in it. For example, Lipitor. Lipitor is used for treatment of cholesterol. It lower the cholesterol level, and if you see the structure of Lipitor, there is benzene ring present. Okay, and similarly there is Zoloft. It is used for treatment of depression. So Zoloft structure contain benzene ring. I will give you simple example that aspirin. Aspirin contain acetyl salicylic acid. If you see the structure of acetyl salicylic acid, there is benzene ring present. Now we will study nomenclature of benzene derivative. So first in this we will study monosubstituted derivatives of benzene. So in this you will take benzene as a parent and substituent as a prefix. For example, this is the chlorobenzene. So here benzene is the parent part. So we have written it here benzene, and this substituent chloro we will take it as a prefix. So it will become chlorobenzene, and this will become nitrobenzene, and this will become ethyl benzene. So sometimes we take common name in IUPAC name. So common name is acceptable in IUPAC name. So this is toluene, phenol, anisole, aniline. These are common name, but it is acceptable in IUPAC name. So this is benzoic acid, benzaldehyde, acetophenone, and styrene. These all are acceptable in IUPAC name. But when sometime the substituent part become long compared to benzene, then we take benzene as a prefix and this part as a parent part. So benzene is carbon 6, and if you see this part, it is C7. So this C7 become heptane, which is parent, and now benzene is the substituent, and whenever benzene is the substituent, we write it as a phenyl. So it will become 1-phenyl heptane. So whenever you will see benzene as a substituent, you can simply write it PH. This represents phenyl. So instead of drawing complete structure of benzene, just write it as phenyl, PH. Now we will do nomenclature of disubstituted derivative. So here we will take example of this 1,2-dimethyl benzene. We can write it as orthoxylene. Now if you will move this methyl to meta position, it will become metaxylene, and now it is called 1,3-dimethyl benzene. So both names are acceptable. This is paraxylene, so it is also called 1,4-dimethyl benzene. Okay, so sometime you can use orthometapara, and sometime you can use locant. Like in locant we give some number 1, 2, 3, 4. So take this example. Okay, here 4-methoxybenzene is the parent part and nitro is the substituent. So you can write it as 2-nitroanisole, or you can write it as ortho-nitroanisole. This is metabromotoluene, okay, and this is also called 3-bromotoluene, okay, and this is para-chlorobenzaldehyde, or you can write it as 4-chlorobenzaldehyde. But in case of polysubstituted derivative of benzene, so we use 4-step process to nomenclature this kind of polysubstituted benzene derivative. So first you have to identify and name the parent. Second, you have to identify and name the substituent. Then you have to assign a locant to each substituent, and fourth, you have to arrange the substituent alphabetically. So take this example. So this is the parent part. This is phenol part. Okay, and now you can give 3 and 5 number to these two bromo. So it will become 3,5-dibromophenol. While assigning the locant, you have to take one thing in consideration, that wherever substituent is, it should get a minimum number. For example, this phenol, this 2-chloro substituent is getting less number, but if you consider it here, so it is getting 6 number. So nearby substituent should get less number. So this numbering is correct and this is incorrect, because chloro is getting 2 number here, but it is getting 6 number here. Now you can try this exercise by yourself and try to give nomenclature of these molecules. So now we will study structure of benzene, and here we will study structure elucidation of benzene. In 1825 there is a scientist named Michael Faraday. He isolated benzene from oily residue left by illuminating gas in London street lamp. So he performed investigation on this oily residue and came out with the formula C6H6. If you know the formula of alkane, it is CnH2n plus 2. So if you put number of n 6, the hydrogen will come 14. So benzene contain 8 hydrogen less, and this hydrogen less could be 4 degree of unsaturation, and this unsaturation could be in normal alkyl chain, okay, or it could be triple bond alkyl, or it could be in some cyclic system. So by now they don't know what is the structure of benzene. So next they performed addition reaction. So generally if there is alkene, if you perform addition reaction on alkene like ethylene, it undergo bromination reaction very easily and give you dibromine product. But when they perform same bromine reaction on benzene, they don't get any product. So they thought, okay, there couldn't be a structure like ethylene or normal alkene structure. So now they have possibility that there could be some triple bond structure, okay, or some cyclic structure which contain unsaturation. Then again they performed bromination reaction in presence of iron bromide. They got C6H5Br, which is a substitution product. And further they carried out substitution and replaced one more hydrogen. They got 3 disubstituted compound with the formula C6H4X2. So they came with this structure, these two possible structure. So now they performed same disubstitution reaction on this structure. They got this product and this product. So but we know that in substitution reaction of benzene we got 3 products, but with this structure we got only 2 products. So this structure was also not possible. So now the only thing remain is this structure. So here you can see they made short double bond and long single bond, because single bond has a bond length of 1.53 angstrom and double bond has a bond length of 1.33 or 1.34 angstrom. So they thought, okay, benzene structure will be like that. So when they performed the bromination substitution reaction on this structure, they came out with the 4 product. So 2 product are 2 disubstituted product. So again these people were confused what could be the structure of benzene. So in 1865 a German chemist Friedrich Kekulé, he suggested a way of resolving this dilemma. He proposed that benzene was not a single compound but a mixture of 2 compounds in rapid equilibrium. So according to Kekulé there are 4 disubstituted products, but the 2 disubstituted product, which one is these, they interconvert too rapidly to distinguish and separate from each other. Okay, so according to Kekulé there are 4 structure of disubstitution in benzene, but 2 structure that rapidly interconvert each other, which are very difficult to separate. Okay, and in 1901 it was confirmed that benzene has 6-membered ring when Paul Sabatier found that catalytic hydrogenation of benzene produce cyclohexane. So by this we know that their benzene contains cyclohexane kind of system which contains certain degree of unsaturation. So in 1930 X-ray and electron diffraction produced a surprising result. According to these 2 techniques, benzene is a 6-membered ring structure. Benzene is a planar molecule and benzene contains 6 carbon-carbon bond and all have same length around 1.39 angstrom, which is shorter than carbon-carbon single bond 1.54 angstrom but longer than carbon-carbon double bond 1.33 angstrom. In other words, benzene doesn't have alternating single and double bond. So earlier the structure of benzene was like that, where there is अल्टरनेटिंग डबल बॉन्ड एंड सिंगल बॉन्ड। कहां तक हमें पता चल गया है बाय एक्सरे और इलेक्ट्रॉन डिफ्रैक्शन से कि जो बेंजीन में कार्बन कार्बन बॉन्ड लेंथ होती है वो कार्बन कार्बन डबल बॉन्ड लेंथ और कार्बन कार्बन सिंगल बॉन्ड लेंथ के बीच में होती है। तो अब इस चीज को हम प्रूव कैसे करें? तो यहाँ पर दो थ्योरी आती हैं, एक आती है रेजोनेंस थ्योरी और दूसरी आती है मॉलिक्यूलर ऑर्बिटल थ्योरी। तो रेजोनेंस हाइब्रिड थ्योरी के अकॉर्डिंग जो बेंजीन है वो कंसिस्ट करता है टू इक्विवेलेंट लुईस स्ट्रक्चर विच कंटेन 3 डबल बॉन्ड दैट अल्टरनेट विद 3 सिंगल बॉन्ड। तो यहाँ पे 2 स्ट्रक्चर है बेंजीन के जिसमें डबल बॉन्ड इन अल्टरनेट पोजीशन है सिंगल बॉन्ड के। ओके, तो ये है इसका हाइब्रिड स्ट्रक्चर। इन दोनों स्ट्रक्चर का ये स्ट्रक्चर हाइब्रिड स्ट्रक्चर है जिसमें इलेक्ट्रॉन मूव कर रहे हैं, डीलोकलाइज हो रहे हैं इस रिंग के अंदर। ओके, तो यहाँ पे 2 टर्म आती हैं, रेजोनेंस कंट्रीब्यूटर एंड रेजोनेंस हाइब्रिड। सो जो रेजोनेंस कंट्रीब्यूटर है दे आर अप्रोक्सीमेट स्ट्रक्चर विद लोकलाइज्ड इलेक्ट्रॉन, उसमें इलेक्ट्रॉन मूव नहीं कर रहे हैं, तो ये है रेजोनेंस कंट्रीब्यूटर और इन्हें रेजोनेंस स्ट्रक्चर और कंट्रीब्यूटिंग रेजोनेंस स्ट्रक्चर भी कहा जाता है। तो ये हुए आपके रेजोनेंस कंट्रीब्यूटर और दिस इज रेजोनेंस हाइब्रिड। इसमें आपके जो इलेक्ट्रॉन होते हैं वो डीलोकलाइज्ड होते हैं, दैट इज द एक्चुअल स्ट्रक्चर। ओके, अब जो केकुले ने थ्योरी दी थी उसने कहा था कि जो बेंजीन होता है उसमें 2 स्ट्रक्चर होते हैं और वो इक्विलिब्रियम होते हैं, मतलब बेंजीन एक नहीं 2 कंपाउंड है और दोनों कंपाउंड इक्विलिब्रियम में रहते हैं जिनको आइसोलेट करना बहुत डिफिकल्ट है। बट अकॉर्डिंग टू न्यू बेंजीन स्ट्रक्चर, बेंजीन का एक ही स्ट्रक्चर है, दैट है रेजोनेंस हाइब्रिड स्ट्रक्चर ऑफ 2 लुईस स्ट्रक्चर। तो अगली जो थ्योरी आती है दैट इज हाइब्रिडाइजेशन एंड ऑर्बिटल थ्योरी। सो इसके अकॉर्डिंग जो बेंजीन का कार्बन है दैट इज sp2 हाइब्रिडाइज्ड और जिसका ट्राइगोनल प्लेनर स्ट्रक्चर है और इनका जो एंगल है that is 120 degree and the carbon has a p orbital with 1 electron that extended above and below the plane of the molecule. So ये जो p orbital होते हैं ये ओवरलैप करते रहते हैं एक दूसरे के साथ, तो ये जो इलेक्ट्रॉन है इसके ऊपर मूव करता रहता है और ये स्ट्रक्चर बन जाता है लाइक डफनट स्ट्रक्चर। जो p ऑर्बिटल होते हैं वो क्रिएट करते हैं 2 डफनट स्ट्रक्चर। ये हुआ डफनट स्ट्रक्चर जो डिस्क्राइब करता है इलेक्ट्रॉन डेंसिटी ऑफ बेंजीन रिंग। सो ये किसकी वजह से हुआ है? बाय ओवरलैपिंग ऑफ 6 एडजेसेंट p ऑर्बिटल व्हिच क्रिएट 2 रिंग्स ऑफ इलेक्ट्रॉन डेंसिटी, one above and one below the plane of बेंजीन रिंग। ओके, और ये एक इलेक्ट्रोस्टैटिक पोटेंशियल प्लॉट है जो बताता है कि इलेक्ट्रॉन की कंसंट्रेशन मैक्सिमम कहाँ है। तो जो रेड पोर्शन देख रहे हैं वो आपको इलेक्ट्रॉन डेंसिटी के बारे में बताता है। तो इसी की वजह से जो बेंजीन में कार्बन कार्बन की बॉन्ड लेंथ है वो इन बिटवीन कार्बन कार्बन सिंगल और कार्बन कार्बन डबल बॉन्ड लेंथ के बीच में। तो दोस्तों ये थी आज की वीडियो ऑन नोमेनक्लेचर ऑफ एरोमेटिक कंपाउंड्स और जिसमें हमने नोमेनक्लेचर ऑफ बेंजीन रिंग सिस्टम पढ़ा और हमने आज की वीडियो में पढ़ा है कि बेंजीन का स्ट्रक्चर इलुसिडेशन कैसे हुई। तो अगर आपको आज की वीडियो पसंद आई हो तो इसे लाइक कर सकते हैं और कमेंट सेक्शन में इससे रिलेटेड कुछ भी क्वेश्चन पूछ सकते हैं। सो थैंक यू फॉर वॉचिंग दिस वीडियो।